Okay, now we talk about partial derivatives and partial differentiation. After today's discussion, you must be able to find the derivative of a function in two or more variables using partial differentiation. Okay, given a function z dependent on x and y, if we want the partial derivative of z with respect to x, evaluated at the point x0, y0, then the partial derivative of f with respect to x is obtained by differentiating f with respect to x while holding y constant or fixed. So the partial derivative of z with respect to x would be denoted as follows. You can make use of the symbol to denote partial derivative of f with respect to x evaluated at x0, y0, or you may express this using the symbol where this one denotes partial derivative with respect to x, and by definition is the limit of the difference quotient f of x sub 0 plus delta x y sub 0 minus f of x0 y0 divided by delta x as delta x approaches 0. In like manner, the derivative or the partial derivative of f with respect to y evaluated at x0, y0 is the derivative of the function with respect to y holding x constant and letting y to vary. This is denoted by the symbol. This would mean partial derivative of f with respect to y evaluated at x0, y0, or we can make use of this notation to denote partial derivative with respect to y, differentiating f with respect to y while holding x constant. Or in terms of a limit, then it is the limit of the difference quotient f of x0, y0 plus delta y minus f of x0, y0 divided by delta y as delta y approaches 0. So if we have the function f of x, y, z, a function dependent on three variables, then we would be able to determine partial derivative of f with respect to x, or the partial derivative of f with respect to y, or the partial derivative of f with respect to z as follows. So the partial derivative of f with respect to x is calculated by differentiating the function f with respect to x, holding y and z constant. Or if it is the partial derivative of f with respect to y that we want, then we differentiate f with respect to y holding x and z constant. And for the partial derivative of f with respect to z, we hold x and y constant and differentiate the f function with respect to z. Now, if we are given a function w dependent on x, y, and z, then the three partial derivatives of the function f or of w would be denoted as follows. This is the partial derivative of w with respect to x, partial derivative of w with respect to y, and partial derivative of w with respect to z. Here are other notations that would denote partial derivative either with respect to x or with respect to y. So if we are given a function of two variables, so we have f function of x, y, then we can determine partial derivative of the said function with respect to any of its independent variable. So we can differentiate f partially with respect to x, or we can denote it as f sub x. And since x is the first of the ordered pair for the independent variable of the function f, then we can also denote partial derivative of f with respect to x as f sub 1. Okay, 1 refers to x, the first of the independent variables. And the partial derivative of f with respect to y can be denoted as f sub y or f sub 2, with y the second independent variable of the function f of xy. Or if we have f function of x, y, and z, then we will have the following. Partial derivative of f with respect to x, or that would also be denoted by f sub x or f sub 1. The partial derivative of f with respect to y, denoted by f sub y or f sub 2. And the partial derivative of f with respect to z, can be denoted f sub z or f sub 3. Okay, let us illustrate how to work out partial derivatives with this particular example. So given the function f of xy equal to 3x cubed y squared, let us find the following. For letter A, the partial derivative of f with respect to x. So how is it done? What we do is we differentiate this function f with respect to x, holding y squared constant. So with 3y squared considered constant, we just multiply this with the derivative of x cubed given by 3x squared, so that the partial derivative of f with respect to x will just be given by 9x squared y squared. Now, if it is the partial derivative of f with respect to y that is required, then given this expression here, we differentiate it with respect to y holding 3x cubed constant. So we have 3x cubed treated as constant times the derivative of y squared, which is given here equal to 2y. So the partial derivative of f with respect to y would just be equal to 6x cubed y. Now, if we are asked the partial derivative of f with respect to x evaluated at 1y, then what we do is we first work on the partial derivative of f with respect to x, and that is given by this expression. We have 9x squared y squared. And since we are asked to evaluate the first or the partial derivative of f with respect to x at 1y, then we replace x in this given expression with 1. And therefore, the partial derivative of f with respect to x evaluated at 1y, which is equal 9 times 1 squared times y squared, or you have 9y squared. Now, as to what the value of the partial derivative of f with respect to y evaluated at 1, 2 would be, then we refer now this particular expression first to what the partial derivative of f with respect to y is, and that is 6x cubed y squared, and then evaluate the value of that expression at x equal to 1 and y equal to 2. So you'll have there 6 times 1 cubed times 2, or we have a 12. Okay, let us now work on the partial derivative of z with respect to x and the partial derivatives of z with respect to y, given that the function of z is equal to 4 times e to the x squared y cubed. Now, in determining the partial derivative of z with respect to x, we will be differentiating 4e to the x squared y cubed with respect to x, holding y constant. So when you differentiate 4e to the x squared y cubed, you will be following the rule to differentiate the exponential function e to the u. Hence, the derivative will be equal to 4 times e to the u times the partial derivative of x squared y cubed with respect to x. When we hold y cubed constant, then the derivative would just be a 2x. Hence, the partial derivative of z with respect to x would be given by 8x y cubed times e to the x squared y cubed. Now, as to what the partial derivative of z with respect to y is, then we will be differentiating z, which is 4e to the x squared y cubed with respect to y, holding x constant. Hence, the derivative is given by 4 times e to the x squared y cubed times the partial derivative of the exponent x cubed y cubed or x squared y cubed with respect to y. And this is differentiated holding x constant. Thus, the partial derivative would just be equal to x squared times 3y squared. And the partial derivative of z with respect to y is given by 12 x squared y squared times e to the x squared y cubed. Okay, in differentiating a given multivariable function with respect to one of its independent variables, the partial derivative is obtained by differentiating the said function with respect to a given independent variable while holding the others constant. And that the rules for differentiation that we applied to single variable functions can also be applied to multivariable functions.